Hi, welcome to Explained. Today I'm going to explain to you Einstein's theory of general relativity, and it's a difficult theory to get your head around, but stick with me. The first thing you've got to appreciate is that the speed of light is a constant that Einstein had to work with. Through careful measurement, through other scientists, this was a realization that the speed of light is the fastest thing that anything can move through the universe, and it is a constant. It is not debatable, it's not an opinion, it's not a convenience factor. In fact, it was very inconvenient for Einstein. So Einstein had this amazing ability to create experiments in his head. They couldn't, because of technological reasons, always be tested. So he said, if I'm standing in a train that's moving at 60 kilometers an hour in that direction, and I throw a ball at someone else over a 10-meter span at 10 kilometers an hour, that ball is traveling at 10 kilometers an hour for the guy standing in the train, but for someone standing outside the train, the ball is traveling at 70 kilometers an hour. Okay? It's 60 plus 10, 70 kilometers an hour. So that's no problem until in the thought experiment you say, well, let's make the train move at the speed of light. Now I'm still throwing the ball at 10 kilometers an hour relative to the train. But for the guy outside observing the train going at the speed of light with a ball, the ball simply cannot move at anything faster than the speed of light. So that technically means the ball will just stand still. And yet, in theory, and it was proven later, if you do throw the ball, it will actually arrive on the other end of the 10 meters. So how does that happen? And this is where Einstein had to come up with a solution in his head, which he so eloquently did. Einstein realized that if there's gravity, things change in the universe. So if you are at a black hole which has extreme gravity, then time moves much slower. In other words, if I'm inside the black hole and you are on Earth and we both experience 1 minute, I would have aged 1 minute, you probably would have aged 10 or 100 years. Okay? So time just moves so much slower close to gravity. So what Einstein then recognized is that there is this thing which he called space-time. And if you think of space-time as a net that's spanning the universe, think of a trampoline. And you put a heavy medicine ball on a trampoline, it's going to indent that. And if you put a little marble, it will run down that net toward the gravity. But it's the gravity that bends the net. And so Einstein realized that this net that we have, think of a trampoline that you put a medicine ball on, it gets indentations from the gravity. And this indentation changes both space and time, in essence, space-time. So let's go back to the train. So although the guy is throwing the ball in the train, it is no longer the 10 meters that we are used to on Earth, given the gravity that we're experiencing. And time also moves dramatically different. So for the guy who's throwing the ball, space-time is much different because of the warpedness of gravity than it is for someone who is, say, just on the tip of that trampoline, if you want. And so the real understanding is that the speed of light is measured in meters per second, and that remains a constant. So if you take the fraction and you say meters at the top, seconds at the bottom, and the constant is on this side of the equation, the only way to make the mathematics work, if time moves relative because of gravity, is that meters must also move relative. And this is the insight that Einstein brought us, that it really is space-time and that it is all relative. So the ball that you throw on Earth, relative to the Earth, is 10 kilometers, but really it is so much faster relative to space, but it is not measured in the same way because space-time in deep space looks much different and responds much different in terms of space and time than what we are used to. So it's a mind-boggling theory. hopefully that gives you some explanation, some recommendations if you want. Stephen Hawking wrote a brilliant book, A Brief History of Time, which is quite complex. The follow-up, A Briefer History of Time, explains it a little bit better, a little bit more simplistic. So that would be a recommendation. If you like this video, hit the like button, tell your friends, look out for some of our other videos. Until next time, this is Louis and you're watching Explained.